Bueno, hoy vamos a tener una presentación especial traída directamente desde Londres, desde el Knowledge Lab. Y para hacer la presentación como Dios manda en estos casos hay que hacer una doble presentación. Primero les voy a presentar a la doctora Rojano. Ella es una investigadora en el área de enseñanza de las matemáticas desde hace muchísimos años. Es una de las expertas mundiales y en México en particular en la enseñanza del álgebra, en los problemas de la enseñanza del álgebra. Y ella les va a platicar quiénes son Richard Moss y Silvia Hoyle.
Silvia Hoyle y Richard Moss son han sido profesores en el Instituto de Educación de la Universidad de Londres por muchísimos años ya. Y definitivamente a nivel mundial pues son gente muy reconocida por su trabajo, sobre todo en investigación, en educación matemática. Son los pioneros en el mundo de haber incorporado la tecnología en la enseñanza de las matemáticas. Pioneros, de verdad, los pioneros, porque trabajaron por muchos años en colaboración con MIT, con Sidney Packard, en la introducción del logo a las escuelas y siempre basados sobre un trabajo muy sólido de investigación. Y en particular en México, ellos también han sido los responsables de que aquí se pudiera iniciar la incorporación de la tecnología a la educación básica, porque pues hay ejemplos de nuestros colegas del CIMESTAC que se formaron con ellos allá, hicieron sus doctorados y después ellos estuvieron, digamos, como consejeros, o como se dice, como asesores de los proyectos nacionales que se han realizado en México para el uso de las tecnologías digitales en la enseñanza de las matemáticas. Hoy en día ellos pues, han recibido ya muchísimos reconocimientos y nos da mucho gusto que seguimos teniendo una relación muy estrecha a través de la investigación, a través de la amistad también. Y bueno, a ellos les da gusto estar aquí porque saben de la existencia de este laboratorio. Ellos también son pioneros en esto de digamos, implementar este nuevo concepto del Knowledge Lab en el mundo. Y bueno, ellos dirigen, el doctor nos dirige el London Knowledge Lab de la Universidad de Londres.
Celia and I are going to share the presentation, and we hope to focus, as the talk progresses, we hope to focus on some general topics that I hope will become in the future a basis for collaboration between the London Knowledge Lab and LITE. I want to just say one word about the London Knowledge Lab, which is, we say, if you can't read at the very top, exploring the future of learning with digital technologies. And this, in English, this has two different meanings. We're exploring the future of learning with digital technologies. Well, there is no future for learning without digital technologies. How is my English? Is it understandable for everyone? Yes. So if you want me to go slower, just... but also we're exploring the future of learning with digital technologies, using digital technologies to try to understand much more about learning in general than we knew before. Whenever a new technology comes into learning and teaching, it's an opportunity for us as researchers to think more deeply about things which usually we take for granted. So we're like fish swimming in the sea. We take for granted that we have the water to swim in, but if something changes in the water, we have an opportunity to look to see what is the problem and what is the sea, what is good about the sea and what is bad. So we're looking at the sea as well as at the technology. Can we learn things about how human beings come to understand by using technology as a window of the learning? I'm going to say a few things about, everything we say will be about computers. But I want to start by saying a few things about the the way that the computer has become a cultural object in our societies before we move on to the main part of the talk, which will be shared between Celia and me on the computer as an agent of change. Agente del cambio, is that okay in Spanish? And so let me start with the computer as a cultural object. It's a very interesting moment, actually, because right up until now, in the UK, we've been discussing how we will find a way to bring technology into the classroom. Where will we find the money to bring technology into the classroom? Who will pay for this technology, and how will we teach the children to use and the teachers to use the technology? And we are at this point just now where this problem is beginning to disappear. Just beginning. We still have some years, but 98 point something% of all children in secondary schools in London, have a smartphone. And as you know, the smartphone is a really powerful computer. It has all kinds of facilities, it has accelerometers, it has the ability to do all kinds of things which yesterday's computers couldn't do. And the iPad is not the answer to anything. Technology by itself is never the answer to educational problems, but it points in a direction where access to really powerful technology is not the problem. The problem is elsewhere. The problem is how to design for this technology, how to help human beings use this technology in the service of learning. Do you know, let's have a vote. When did the first electronic calculator become available? Everybody just think of the answer. Which year did the first electronic calculator become available to buy? Okay, if you think it was before 1950, put your hand up. One, no, maybe not. 1960, 1970, 1980, quite a lot of 1980, 1990. So you see, the young ones think it was 1980. It was 1974, and in 1975, I went to a conference of math teachers, and there was only one subject for debate. Will we ever arrive at a situation where every child could have a calculator? And the answer was no. It's just too expensive, it's too difficult, and what about training the children how to press the buttons? And it was just inconceivable. Well, that's only 30 years ago. And I think we will look back, of course the time scale is compressing, so in 5 years I think we'll look back and say, why were they worried about finding technology? Technology was never the problem. I'll show you what the problem is. 1 week after the iPad became available in the UK, I thought it would be interesting to look to see if anybody was thinking, how should we use this in mathematics education? And I found my first example. And here it is. How do you add 86 to 49? And the iPad gives you a multiple choice of 1, 2, 3, 4, 5 answers, and then it tells you if you've got the answer right. So here we have the technology of the 21st century with the pedagogy of the 19th century, maybe even the 18th century, I'm not sure. And of course things have changed now. People are beginning to use iPads in education, in maths education even, for interesting things. But it does take time, because the first thing that always happens when there's a new technology is people try to do with it what they did before with the old technology. It seems like a natural evolutionary law. Okay, how many people know what this is? Oh no! If you have played Angry Birds, can you put your hand up? Oh really? Okay. So, Would you like to guess, I'll tell you this time, how many independent downloads there have been for this program? Millions for sure, but that's the wrong order of magnitude. The right order of magnitude is 300 million. 300 million. And this is already 6 weeks out of date, I don't know. And we have to ask ourselves, what is it about this completely crazy game of shooting birds out of, what do you call them in English? I don't even know. Catapults, yes. What do you say in Spanish? Okay. And then you kill the pigs and... Actually, there is... The more you play it, it's like a drug, actually. It isn't quite so stupid as it looks. And I am very interested personally to answer my own question. What is it about this that is so attractive? This is a very big number. I mean, it represents a significant fraction of the total population of the world. I mean, that's an incredible thing. And before we dismiss it as just a stupid game, we should at least ask ourselves, can we learn something from this about education? Can we borrow something about this? I'm personally convinced that, you know, when the buildings collapse, they collapse very realistically. And there's a very powerful physics engine underneath the system, as you probably know. I think without that, it would lose its appeal. And if that's true, then that's quite an optimistic thing. People are interested in how the world works. I don't know. I just wish I could write probably you wish you could all write a program like this, then you could be very rich. But there is a lesson, and here's the lesson. What we give people, I don't know if you can read it, what we give people to learn in formal education must be at least as powerful and as engaging, as motivational as what people use in their informal learning. And sometimes, if you remember my example of the addition problem, sometimes we must have kids going to school now who are more or less laughing at what we are asking them to do, because what we're asking them to do is just the tasks of the 19th century and they live in the 21st century. Okay, let me move on now to the computer as an agent of change, cultural change and education. And I want to share with you an example which is going to be symbolic for the rest of the talk that Celia will give. And it comes from the collapse of the world banking system in 2007. Well, it's still collapsing. I'm not sure when it will stop collapsing, but it began in 2007. You remember the banks, Lehman Brothers and so on. And this is a quotation from the financial director of Goldman Sachs. At the time, the second biggest investment bank in the world, but now the biggest because Lehman Brothers doesn't exist anymore. And he says, we were seeing things, 25 standard deviations on several consecutive days. So this man has in his head a model of how financial markets behave. And it goes like this. Everything is normally distributed. I'm sure I don't have to explain what this graph is to you. Everything which happens randomly gives rise to a normal distribution. And you can see at the end, these are the standard deviations, 1, 2, 3. And you can imagine where 25 is, it's probably somewhere in the street. And the probability of being in the 25th standard deviation is unbelievably small. And I thought it would be a good idea. I asked my son, who works in the Bank of England, he said he would work out for me, what is the probability, how long would you have to wait for something to happen in the 25th standard deviation several days in a row? And the answer is 10 to the 124 times the life of the universe. Now, this is a very interesting thing, because what the Goldman... Obviously, this is ridiculous. This is completely ridiculous. And the only explanation is that the normal distribution is not a good model. And there have been many financial mathematicians saying that it wasn't a good model for many years before 2007. And so the point of this example is that modelling and understanding what a mathematical model is really not part of any of our curricula. I'm sure it's not a part of the Mexican curriculum. I'm absolutely sure it's not a part of the curriculum in the UK, except in a trivial way. And yet, modelling is the future of the way people are thinking. If you haven't got in your mind what a model is, you can't make sense of global warming, you can't make sense of financial catastrophe, you can't make sense of how human beings relate to each other. So, of course, if you're not a mathematician, if you're a physicist, okay, if you're a chemist or a biologist, but if you're just an ordinary person, what can you learn about mathematical modelling? It just seems too difficult. And we want to argue that it doesn't have to be as difficult as it looks, and what's more, technology provides us with an incredible opportunity. Here's how I'm going to start here with the ending, really. This is the end of the story, which is that some ideas look more difficult than they really are because of the way they're represented. It's not that the idea itself... Imagine how hard it is to represent, I'll borrow one of your examples now, to represent the motion of I can't speak English today, a projectile being fired from a gun. Imagine how hard it is to represent that if you don't have calculus. But as soon as you have calculus, it's really just two equations. So I'm going to give you an example of what I mean that is more everyday. And here it is. This is a photograph of one of the beautiful things I'm sure you see here. Maybe not in Mexico City, but I used to have a video. It's really beautiful video, and you've seen it happen. And anybody who sees this happen asks themselves the same questions. How do the birds know where to go? Which bird is in charge? Where do the birds have a conceptual map of where they're going? And so on. It's an incredible phenomenon. And once you start to look at phenomena like this, you can see them everywhere. Nothing to do with birds. Well, this is, of course, like most things, there's a beautiful mathematical model, and here it is. I promise you this is the correct mathematical model, but you don't have to study it. I must just tell you that the last time I showed this model in Bulgaria, one of the people in the audience leapt to his feet and he said, "But this is my model," and I derived it with one of the people who are referenced. His name is Posner. So I'm sure that this model really is correct. But of course, this is a real mismatch. Here you have a beautiful phenomenon that you cannot begin to understand, and here you have the mathematician's answer to the phenomenon, but it's not an answer which we can expect the person in the street to understand. But I'm going to show you an example now. This is, how many people here have seen Net Logo? I'll explain what the model does in a minute. And very quickly, you can see they know which direction to fly, and they begin to clump together. Now, you may say, okay, well, this is a very powerful mathematical model, and it's not very accurate, and so on. But actually, this model, you just have to trust me. There is a computer program built in Logo under here. All you need to know is each bird has to see which bird is nearest to him, or maybe her, and then the bird has to make a judgment about what angle to turn through, based on the difference between the neighbour's direction and his direction. So it's a very simple, each bird only knows two very simple things. And because I have here a very powerful tool, a programming language, it's called NetLogo, it doesn't belong to, it wasn't us who invented it. It was invented by Mitch Resnick of the Media Lab in Cambridge and Iri Walensky from the University, Northwestern University. I can give you the references, it's open source. But the point is, if we have powerful engines, we can describe phenomena in very simple ways that would not have been possible without the technology. So I'm going to hand over to Celia, who's going to ask, is this my slide or your slide? I can't remember.
You do it.
I'll ask you because it's in Spanish. Two questions. What is this example of the birds just a stupid, crazy example? We think not, and we think that it points in the direction of what kinds of things people need to know in the 21st century. That's the first question. What do they need to know? What do we need to know? And the second question is, if we know what we need to know, then how do we help people to learn it?